Hey, engineers, and welcome to 2.2, I believe, which is Introduction to the Manufacturing Process. Have you ever watched an episode of How It's Made? I do. I watch these things. I just get sucked into them, how just random stuff is made. Like, for instance, how is a pencil made? Well, here it kind of shows how they get sharpened. Like, look at this clever way and how they're just running it across sandpaper to sharpen that pencil. Like, what sort of cool, processes are involved with making the stuff that we use every day? There's really clever solutions inside of factories that talk about how stuff are made. You know, ice cream sandwiches, sugar, bubblegum, honey, jawbreakers, peanut butter, Domino's pizza, how it's made, mozzarella, spaghetti, handmade leather iPhone cases, crotch rockets. It just goes on and on. Everything that we use is made somehow. And we're going to talk today a little bit about the processes involved with making something. When you make something, when you buy a Yeti cooler, man, why do those freaking coolers cost $400? Right? It doesn't really cost $400 to physically make it. It maybe only costs $40 to make, but the marketing, they slap their name on the side of a NASCAR, they slap a billboard up, they put an ad on the internet. Like, sales and marketing is 25% of that. They're spending $50 doing that. How much do they keep in profit to pay everybody? And then to actually engineer and design the material is a substantial amount too. But the biggest amount when you're in a product is actually making it. Physically, how much does the material cost? We have to manipulate that material in different processes, pay the people to do that. A sequence of operations to create a specific product. That's what we call the manufacturing process. When you manufacture something, you're doing something in this sequence to make it. There are different engineers. My wife was she is an industrial engineer, so she would actually be in a factory. How can you make materials travel through the factory faster? Like ergonomics. Don't bend over to pick your part up. Move all the parts higher, and you can do these faster. Manufacturing engineers. What machines are really expensive. Like, some of these CNC machines are in the millions of dollars. But if it moves faster and you can create more product, does it actually make you more money? So trying to figure out what the best solution is to make the thing that you're trying to do, and then to select the different materials. Like, what are we going to make our object out of? There's different types of shops. Maybe you make only one thing and you have very small tools. They're very generalized tools. And the part moves inside of your little shop. They call this a job shop. Small quantities, large, you can make all sorts of different stuff. Imagine like a woodworking shop. You can make all sorts of different stuff. In a flow shop, the material starts traveling through very special machines. Like, you have an injection molder, or you've got a CNC machine, something very specific to make something. A linked cell. So now you get into okay, we have a paint department. We have a machining department. We've got a sheet metal department. We've got a ceramic department. We've got a light assembly department. We've got shipping. So now you start putting different pieces inside of a larger whole. Auto manufacturing, any large plant works in this way. Maybe the material can't flow. Maybe it's what you're building is so big you have to bring the shop to that. And this would be like a project shop, like building ships. Like, you have to go to the ship when it's happening. Bridges, large machinery. Or a continuous process. A lot of chemical plants, like, it flows through a series of pipes to create their product. Lean manufacturing means that you try to use your time wisely and you try to use your materials wisely. So you're not, it's you try to trim the fat, which is, there's no downtime. People are always busy. People are they're using their time the most efficiently. And all employees are doing what's called quality control. Like after you make maybe 50 parts, you check every 50th one to make sure that the machine is still doing what it's supposed to be doing. Some of the basic manufacturing processes: casting, forming or metalworking, machining, joining and assembly, rapid prototyping, other. Casting, that's when you take a molten and then you pour it into a mold to cast that. So when you cast your part, it's never really finished. You need to machine it or sand it or paint it. It is rarely ever finished at that point. Anything that is waste, you just throw it back in, remelt it back down. Very recyclable. In basic casting, you make a mold. You pour that molten in there. Sometimes you can get multiple use. Sometimes it's single-use molds. The material is heated to a very specific temperature, poured into the mold, and then it's removed. Forming and metalworking. After things have been cast, or then we start to refine it, make it to a very specific shape, and we can do this through hot or cold forming. So you can roll a material. So in blacksmithing, you've maybe seen forging. You can extrude it. So like if you think of the Play-Doh Fun Factory, where you push the Play-Doh through a hole, you can extrude metal in that way. Drawing, so you send it through a hole, and those holes get progressively smaller, so it makes this thing, they call it a die. It makes it smaller and smaller after each one. You can cold form, where you just shape something by sheer force. Machining, it's where you remove material through different processes. You can use a lathe, which you spin you spin the object, and then you remove material to make things round. You can have hand lathes, or you can have CNC lathes. So you can do all sorts of things, make things straight. You can taper them, contour, make specific shapes, turning, facing, forming, necking, parting, cutting it in half, boring, put a hole in it, threads in it, and then knurling. If you've ever been up in the weight room, that like cross thatch pattern that's on the weightlifting bars, that's called knurling. So you can get like a grip, and it won't make it so slippery. Milling, it's weird. Milling is like a drill, but the drill can go sideways. So you spin this, it's got a really special drill bit, and it cuts as it spins sideways. So you can cut holes. You can make the surface very flat. You can dovetail, slab milling. You can drill, put holes in an operation. I was a machinist when I was in high school and into college, and I used to drill holes and do milling and lathing. That's all we did on different lab equipment parts. Drilling, counter drilling, step drilling, boring out, counter boring, counter sinking. That's where you put like a hole and it like flares out. Reaming is when you open up a hole to a very tight tolerance, like thousandths or 10,000ths of an inch. Tapping is when you put threads inside of a hole. Shearing is big scissors. You can take sheet metal and you can cut it. You can cut things. You can put holes. So you can like punch holes for, maybe you need a plug, like a USB plug that goes in there or something. You can do all of that. Notching, lacing, trimming, perforating. Abrasives, sanding. So this machine right here, you throw your parts in it, and it's got all these rocks in there, and it tumbles it around to give it like a really cool, to take any of the burrs off, and it puts a unique shine. This part, I mean, this is on my desk. If you ever get a chance to get close to it, it's got a really unique pattern on there, and that was done by that machine. This was some of the parts that we used to make in the factory that I worked in. You can do thermal or chemical processes. We would chemically etch names on our steel, like a lot number. So if something ever went wrong, we could track which parts had that steel, so we could recall it from the consumer to replace it for them. Or you can heat treat things. Chemical, electrical discharge. That's cool. Man, these are all great things that I know a lot about, but I'm sure that you don't. We just don't have time to get into a lot of them. Really cool. Heat treating. If you want to make, how do you make a drill bit that's made out of steel, drill through steel? How do you make that harder than the other one? Through heat treating. It says it can also occur incidentally during the manufacturing process. Like if you push your drill bit too hard, you can heat it up and then it wears it out. So that's why we use coolant on a lot of things. Joining. I used an example of that mechanical pencil in the previous video. How do you hook these things together? Like you can make them physically because it snaps. There's like a little hooks together. I don't know if you can hear that. Or maybe it's glued, or maybe there are threads that hook this together. All different ways to assemble your products. Mechanical fastening, screws, nuts, bolts, soldering, brazing, welding, and adhesives. Mechanical fastening, you could build that if you've ever had to like pull something like a lever. Think of like those locks on a life jacket. That's a mechanical fastening. Using rivets, nuts and bolts, cotter pins, edge design, like they lock together. Any plastic part, like your phones, like they're all mechanically, or using adhesives. Welding, you get enough heat to melt two metals together, and then you maybe put a little filler in there to fill the excess. Using adhesives, we can use glue. I mean, there's all different types of glues. Resins, oh boy. Soldering and brazing. I feel like Adam Savage, if you know that guy, he's all about manufacturing and how do you make something and all these. Soldering, when you need an electrical connection, you would solder two wires together. It's like hot glue with metal. Rapid prototyping, that's 3D printing. So a way to, how do we make a part quickly? And that's hence the name rapid. Sometimes it's not so rapid. If you've 3D printed something, maybe you're like, this took a long time to do. And there's all different types of 3D printing. There's SLA, which is stereolithography. Laser sintering, so you can 3D print out of metal. So they're using a laser to melt the powder on top of the layer before it. FDM, that's the typical 3D printing that you are used to, where it's like a glue gun putting layer on top of the other layer. Stereolithography is using a projector. They use a projector screen that uses UV resin, so you can flash an image from below into a resin, and that image is made in ultraviolet light, and it will cure the resin, so that you pull it from below and it like keeps snapping pictures, so it's kind of crazy. Finished parts, you can print them, they work, you can, all sorts of stuff. Testing, transportation, material handling, and packaging. Material-specific manufacturing processes, plastic processes, ceramic processes. There's definitely very specific things that we do to very specific materials to work with them. With plastics, one of the big ones is extrusion. Like, how does it's called extrusion molding. It's really cool. I'll show you a whole other video. I mean, this is basically what made the modern age possible with this molding process. There's a screw that goes and it like creates so much friction that it melts these plastic pellets, and then you inject it into this mold, injection molding, and then you open up the mold. Casting. Maybe you've heard of Yeti coolers. They're called roto molding. They're just putting a mold, and then they're rotating that mold around to make it go into all the corners, top, bottom, left, right, forward, backwards. So that's, if you ever heard the word roto molding, that's what it means, rotational molding. Blow molding, 2-liter bottles. You put them in there and you can just inject air and it expands like a balloon. Thermoforming, you heat it up. You saw, I think, we watched a video where you just heat up a piece of plastic and they use a vacuum to pull it into a sheet. Reaction molding, where you can use chemical reagents. So I used to do reaction molding when I was in, that's how they ship a lot of stuff. If you ever get a box that's got foam around it, we would put our part in there and they would inject in this foam that would expand and then harden. And so they would actually mold it to the box so you wouldn't break your really expensive part through shipping. Ceramic manufacturing. I used to do this. I would make ceramics in our ovens. It was a jackhammer with this rubber end, and we would put this stuff, it was like a concrete, and we would like use a jackhammer to put it in there and then fire it in an oven to make more ovens. Again, manufacturing is crazy. It's really cool. We're going to watch a lot of videos on how it's made, and we're going to see and pick out these different parts of the manufacturing process.